Everyone. I'd like to first thank the organizers and thank you all for sticking around this afternoon to hear these talks. I am from Ohio State, from the Department of Food, Agriculture, and Biological Engineering. I'm also a researcher with Ohio Sea Grant and at Stone Lab, so I want to acknowledge them as well. Thanks to Randall. He invited me to present today and assigned me this topic, so I guess I should talk about best management practices. There was no consultation regarding the topic, but it's pretty much right on. Thank you, Randall. So that being said, there's three things I'd like to focus on today. One of those will be using watershed models to evaluate management plans to reduce phosphorus runoff. We've talked a lot about phosphorus runoff today, so we're using watershed models to look at that. I'd like to spend just a little bit of time talking about forecast tools. These are some recent developments from the Ohio Department of Agriculture. And then I'm going to wrap up today talking about public-private partnerships. And this is something new that we've been thinking about at Ohio State and with some other collaborators across Ohio as a way to locate best management practices to address critical source areas. I'm going to go ahead and start with watershed models. So most of us are aware that back in 2015, Ohio, Michigan, Ontario, they agreed on some targets for phosphorus reduction. And you can see those targets on the slide. There's a target for dissolved reactive phosphorus. There's a target for total phosphorus. There are spring targets. There's summer targets. So there's a lot of different targets. They are consistent, so it's a 40% reduction roughly for all Western Lake Erie Basin. It's a 40% reduction for what's coming out of the Maumee watershed as well. And so what's really guided our watershed modeling effort is to determine, can we reach these targets, or how can we reach these targets, and what practices and what adoption rates can get us to those targets. And for this, we've been focused on the Maumee River watershed in northwest Ohio. The Maumee watershed is the largest watershed that empties into Western Lake Erie Basin. That's one of the reasons why we're focused on this watershed. It's also the largest watershed in all the Great Lakes. There's also really strong correlations between the discharge of phosphorus that comes out of the Maumee River and the size and extent and severity of the algal blooms that we see in Western Lake Erie. So to be succinct, if you really want to address or reduce harmful algal blooms, you're going to focus on the Maumee River. I'd also like to take just a second to kind of explain the rationale behind the watershed models that we're working with. So a lot of us here are familiar with Kevin King's work, the edge of field work, and that is likely, possibly some of the most important data that's guiding our decisions about production and water quality in the Western Lake Erie Basin. The edge of field data gives us field scale data about exactly how different practices that are applied on a field affect the amount of phosphorus coming off that field. So we have a good idea about how some of these practices, such as subsurface implementation or subsurface application of phosphorus, can reduce the amount of phosphorus coming off a field. But when we try to answer the question across a large watershed like the Maumee watershed, which is 17,000 kilometers wide, we need to be able to extrapolate, to take that data that Kevin has at a field scale and extrapolate that to a watershed scale so that we can answer some of these questions about what types of practices, how many of these practices do we need to reach that 40% reduction. And so that's what really drives our watershed modeling projects. This is just an example of some of the practices that the watershed models we develop are capable of analyzing, and I don't expect you to be able to read all this text here. There's a number of best management practices that we can analyze, and we can also analyze different degrees of effectiveness of these practices, so we can put in different coefficients in the models to have a buffer strip that removes 80% of the phosphorus, or we can put in different coefficients to say it removes 40% of the phosphorus. So there's different ways we can parameterize these models to analyze different types of BMPs and different rates of effectiveness of these BMPs. The one thing I did fail to mention is that these watershed models are called SWAT models. Some of you may have heard of that. That's an acronym, Soil Water Assessment Tool, and that's the name of these models. And they are probably the most popular and probably the best models to analyze agricultural landscapes. That's why we've chosen to use these types of models. To give you a little history of these projects, a group of us did complete an initial study of different types of management practices in the Maumee watershed a couple years ago. This study was led by the University of Michigan. Since that time, we've kept the band together. We've kept the same groups of modeling teams together. We moved the leadership from the University of Michigan to Ohio State now. And so now we're in kind of our second round of studies. And the goals of these current studies are to analyze different and perhaps more feasible scenarios. So we're learning through surveys and by working with stakeholders what types of management practices are more likely to be adopted by producers. And we're also trying to analyze the impacts of climate changes. So quite a few speakers today have talked about there's more likely to be heavier, more intense rainfall events. So what types of management practices are we going to need to counteract those changes in the climate as we move forward if we want to try to reach or maintain that 40% reduction? One of the things that makes our modeling effort unique is that we don't just depend on one model. So as some of you may know, when we construct these models, a lot of the choices we make are personal based on that model or subjective. And so each model has a set of biases depending on who developed it and how it was calibrated. So instead of depending just on one model, we actually have a group of 5 or 6 models. So you can see the different institutions listed on this slide. So each one of these institutions has its own independently developed SWOT model. So by analyzing the same management scenarios with this group of 5 or 6 models, we can have more robust predictions. We can see how well all these models agree or disagree. So we can be a little bit more confident in the estimates of the impacts of different best management practices across the Maumee watershed. Last thing I want to point out, it's always good to acknowledge where the money's coming from to fund these. And so the money for this current effort is coming from the Ohio Department of Higher Education. And just to acknowledge them, they've actually contributed quite a bit of funding to address the problem of harmful algal blooms, not only in Lake Erie, but also in the watersheds as well. So it's a really important initiative from the Ohio Department of Higher Education. Another thing that makes our modeling unique, I think, and it's a really good resource for us, is a really strong collaboration with stakeholders. Moving from the past project to the current project, we've actually broadened the stakeholder representation. Now we have representatives from agricultural communities, environmental organizations, and government agencies. And they provide guidance in a lot of different ways. This includes interpretation of survey results. So how do we use surveys to guide the scenarios we're analyzing? They help us develop feasible scenarios. So what types of management practices are actually likely to get adopted by their constituents? That's really helpful to us. As we move from analyzing results or analyzing scenarios to having results, we hope that they'll work with us to promote these results and advocate changes in management based on these results going forward. And throughout these modeling projects, they've suggested improvements to the models, helped us find limitations, and they've been very helpful in helping us access new data streams to better calibrate our models moving forward. So a lot of good ways, good reasons to stay in touch with stakeholders, and a lot of good guidance they've provided us. So what I'd like to do now is just give you an example of how we've moved from an initial modeling project to what we're doing now, working with surveys of producers and working with stakeholders to kind of guide the scenarios that we're analyzing. So going back to that first set of modeling projects, these 3 best management practices you see here were bundled together to produce one of our most successful scenarios. And you can see the adoption rates that we had for subsurface placement, cover crops, and buffer strips in this scenario. And so moving forward from that, we've worked with Robin Wilson. She's another faculty member that we're fortunate to work with at Ohio State. She has done a good amount of surveys in the Western Lake Erie Basin, and some of you may have responded to those surveys or possibly chosen not to respond to those surveys, so I can understand that for sure. A lot of surveys we get these days. The first thing you see by looking at these surveys over these 3 years, 2011 through 2017, is there's an increased adoption of subsurface application cover crops. That's pretty encouraging, and that's probably not anything earth-shattering to this audience here. What these also show moving forward is that Robbins also asked the question about what types of management practices are you likely to adopt in the future. And here you can see that those numbers greatly increase if we look at that second from last column. So we have a likely adoption rate of subsurface application up to 60%, 68%, excuse me, and 60% for cover crops. So those numbers are getting pretty high, and that's encouraging. If we compare those numbers to what we had in that past scenario, the likely future adoption for subsurface application cover crops is actually greater than what we had in that past scenario. One thing that was a bit unrealistic in that past scenario was a 78% adoption of vegetative buffer strips. So our stakeholders told us that that's pretty unrealistic, that you're going to get that many producers to sacrifice productive areas for a vegetative buffer strip. So going forward, we've tried to look at more feasible scenarios, something that would actually have a better chance of being implemented in the field. And so what we've done is we've just taken those likely adoption rates in the future and plugged those into the more feasible scenario. And by doing that, let me go backwards here, by doing that, we're able to back off on that vegetative buffer strip to something around 50%. So working with stakeholders and working with surveys, we're actually able to comprise more feasible scenarios and see how and if they can meet these targets in the future. So with that being said, I'll summarize some of the current scenarios we're evaluating with this present modeling study. So we have an observed number 1 where we're doing in-field and edge-of-field practices, and you can see cover crops, buffer strips, and placement at a 50% increase over the baseline. And this is the same scenario that we ran in the past model so that we can compare apples and apples. Number 2 is a likely adoption rates, which I mentioned before. Number 3 is in-field practices with wetlands. We're also doing in-field practices with drainage water management. We've heard quite a few people talk about drainage water management. A 5th scenario is looking at fertilizer management, so perhaps reducing fertilizer management to match crop removal rates, perhaps reducing fertilizer application by 25%. We're also trying to increase soil organic matter. So we heard Jim Horman talk about the importance of soil organic matter. So if we're able to increase soil organic matter by 5%, what effect would that have on phosphorus coming off of the Maumee River watershed? And then lastly, we're looking at climate change. So I did mention that that's a focus of what we're doing as well. So we're running quite a few scenarios looking at climate change in the future. One thing I'll mention here, I'm not going to show any results from this today. We're still analyzing these outputs and kind of combining the outputs of the different 5 or 6 models we're working with. We do have a meeting in 2 weeks with our stakeholder groups, so during that meeting we'll look at these results, interpret them. I do anticipate that probably halfway through this year we should have a final report and be able to share those results with everyone. One of the things we're excited about, and we always try to do as we move forward with these models and move from one study to another, is that we try to improve the models. These models are not perfect, and there's always ways we can improve them over time. One of the ways we're improving them right now is to reduce the resolution of these models. So in the past, there's some variation looking across the 5 or 6 models that we have. We're at a spatial resolution of perhaps 10 kilometers squared, which is pretty large. What we're able to do now, or what we're able to do in the near future, would be able to have a field scale SWAT model with a HRU size of about 1 kilometer squared. So that'll be the resolution of our model. And what we think is really important here is that we're calling this a field scale SWAT model. So the resolution of our modeling will be at the resolution of a field. And as you know, that's the resolution of management, or more close to the resolution of management. So if we can get close to our model resolution to the resolution of management, then we're closer to replicating reality and being able to implement some of the management techniques that are actually used on those fields. We're also looking at refining some of the manure use assumptions and manure application assumptions. This has been done with Kevin Elder, I see in the audience here, by looking at confined animal feeding operation data from Ohio, Michigan, and Indiana. We've also worked with Teresa Dirksen in Mercer County to get some better idea of how the manures moved around in the southern edge of the watershed. So we're excited about these advancements. This is being led by Dr. Margaret Kalsick at OSU, who's in the audience somewhere, I believe, right here. Hi, Margaret. And Margaret's been collaborating with some of the faculty and researchers at University of Michigan to move this forward as well. So what I'd like to do now is talk just briefly about some new forecast tools, and this is something that's being developed by Ohio Department of Agriculture. I haven't been a part of this at all. I just want to promote this a little bit if I can. So one of the tools they have is a 24-hour precipitation probability map. Okay, so those of you who are familiar with Senate Bill 1 for the Western Lake Erie Basin, not advised to apply fertilizer when there's a 50% likelihood of a half-inch of rain in 24 hours. If you go to this tool, it's on the ODA website. It'll tell you if there's a probability, 50% probability for half-inch of rainfall. I looked at this last night, 10:35 p.m. I put the official time there so I would remember, and you can see there's a bit of precipitation for kind of the whole state of Ohio, but not a whole lot. So anyway, if it was above 5, you would start to see those blue colors. Logan mentioned earlier that it's important to document, so this would be a one-stop shop if you do want to document what that probability is. So based on what Jim has said and Eileen just mentioned, we also know that runoff is not just based on rainfall, it's based on soil properties as well. So moving forward, this is another tool that you can also find on the ODA website. There's a tool called the Ohio Applicator Forecast, and this combines not only weather forecasts from the National Weather Service, but also soil properties. So it looks at soil moisture, slope, soil type to predict runoff. So this doesn't exactly match Senate Bill 1, so it's not a one-to-one match with the regulations like the last map I showed you, but this is kind of going forward to improve the predictions to bring in some of those soil properties to look at runoff. And this tool, a similar tool, is already online in Wisconsin, Minnesota, and Michigan. There's a beta version. If you go to the ODA website, it's on the front page of their website. You can see this for Ohio, and if you want to, you can use this to guide management in Ohio as well. So I just want to mention these tools are out there. All right, the last thing I want to talk about today, and I do want to hopefully leave some time for questions at the end, is using public-private partnerships and forming these partnerships to locate best management practices to critical source areas. And so there's a few things we know about the Western Lake Erie Basin. One of the things is that we know that there's critical source areas, or sometimes these are referred to as legacy phosphorus areas, with greater levels of soil test phosphorus in them. Okay, and an example of that, if we look at the Ohio counties within the Maumee Basin, about 5% of those acres have soil test phosphorus levels above 100 milligram per kilogram Malic 3 phosphorus. And if you look at some of the counties that have a historical a history of more livestock, such as Mercer County or down the southern portion of the basin, you're going to see a little bit higher values, or maybe 10% of those acres have something greater than 100. So we know that these areas are out there. We also know that these areas are, on average, likely to contribute greater amounts of phosphorus runoff than those with lower soil test phosphorus values. And so this is some data that Kevin King has generously shared from his edge of field work. And on the top part of this graph is DRP concentration. And so if you look at the very bottom of the graph is your Malic 3 soil test phosphorus, ranging from 0 up to more than 400. So if you look at the top, that's DRP concentration, and the top left is spring. The top right is looking across the water year. The main point is that once you move past 100 Malic 3 phosphorus values, you see that those DRP concentrations edge higher, okay? If you look at the bottom part of that graph, that's the DRP load, and you see the same trend there. So once you move past 100, there's a bit of a threshold there. You see that that DRP load is above 100 kilograms per hectare. So we know that these areas contribute, on average, more phosphorus than areas with lower soil test phosphorus. So in order to manage these, one idea would be to try to locate best management practices to these fields, to target them to these fields. But there's a bit of a challenge there because the soil test phosphorus results are proprietary data. No one, not too many people want to hold their hand up and say, hey, we have a field with really high soil test phosphorus values, and I think most of us can understand that motivation. So the way we're trying to address this challenge is by forming these public-private partnerships, or PPPs, if you will. And the idea here is to collaborate with nutrient service providers and/or certified crop advisors to recruit farms to adopt BMPs for the treatment of these critical source areas. So just to give you an idea of how this would work, first of all, why do we want to work with nutrient service providers or certified crop advisors? Well, they have the soil test phosphorus values. They work with clients, and they know, based on that soil test phosphorus values, they advise those clients how much fertilizer to put on, what type to put on, things like that. So they have the soil test phosphorus values. They know where the critical source areas are. So they can, in confidence, approach their clients, say, hey, there's a field you have that has 200 milligram per kilogram phosphorus. There's a group at Ohio State that has some funds that would like to put in BMPs next to that to see how effective they are to treat this elevated phosphorus soil that you have. Are you interested in that? If at that point that producer says, yeah, I'd like to do that, I'm interested, that certified crop advisor can put them in touch with folks at Ohio State Extension will work with that producer to put in the BMP that producer wants and the BMP that makes the most sense for that field, for that cropping system. If on the other hand, that farmer says, no, I don't really want to do that, for whatever reason, then it just ends there. There's no more sharing of data. Just the farmer and the crop advisor know about that just as it was before, so it ends right there. So by working through the crop advisors, their kind of trusted source of information and guidance for farmers, we feel like this might be a way to move BMPs to these critical source areas. And by doing this, there's at least a couple important questions that we're trying to answer here. One is, can these public-private partnerships be effective? Can we form them? Can we use them to target conservation practices? And can we improve water quality while maintaining agricultural production? That's really one of the big questions there. And then the second question, I think one of the hypotheses that a lot of us have is that if we can locate these BMPs to these critical source areas, we'll get more bang for our buck. We'll be able to reduce greater amounts of phosphorus than we would if they were put on fields with lower amounts of phosphorus on them. So by doing this, we'll be able to hopefully answer these questions, which are important questions. So what have we done so far? So far, we've formed a strong collaborative team, and you can see some of the members of this team, their logos on this slide right here. And with this team, we've submitted 2 pending proposals. One of those is to the USDA. They have a program called Water for Food Production Systems. We submitted to them last August, and it's still pending. The government moves slow sometimes, as you know. Some of the budgets are uncertain, so we're looking forward to finding out about that shortly. We did very recently just submit to the Great Lakes Research Initiative, so that'll probably be a little more lengthy process. We're always searching for more partners, and we're looking for better ideas on how we can improve this approach and see if it makes sense to producers and to people that are out in the field. So with that, I'm going to wrap up, but I would like to leave some time, and I would welcome comments about anything I've mentioned today, especially this public-private partnership idea. So thank you for your attention.
Looks like we have one quick question up in the front.
Some of the soils in the Maumee watershed are naturally high in their ability to supply phosphorus because of their mineralogies. Was that factored into any of the models to try and explain why some soil test P's levels were so high?
So I think there's a couple questions there. One is, how do we factor in different types of soils in the model? So we start the models with the kind of usual Surgo soil map. So we do look at some soil differences. The one thing that we don't have in the models are soil test phosphorus values, just because there's not much of a data set with a high enough resolution to put them in the models that we have. Now, that was two parts of the question. Maybe there's a third part of trying to factor in some soil types, relating that to some of the soil test phosphorus values and using that to try to target BMPs. So that would definitely be one of the things we look at. If there's a high or low soil test phosphorus value, and see how that relates to soil type and how that's going to affect how much phosphorus is coming off, that's something that we're going to look at, especially when we look at different types of BMPs, which BMP would be more or less effective on one field versus another, one soil type versus another. Does that answer your question a little bit?
Daniel Baldoff has a study for her master's down at Ohio State where actual soils in the Great Black Swamp were sampled. So there's actual data and tied to GPS coordinates.
Great. Thank you.
Do we have more questions for Jay?
What have they, Ohio EPA classified the lake as right now? Is it critical yet?
I don't think so, but I believe that's, I'm not sure where it stands, but I believe that's been reopened, and it might be moving in that direction, but I don't think it's happened yet. So,
Well, the reason I ask is because we got we have an ex-representative in Toledo, name is Mike Ferner, and he's trying to get the federal EPA to classify that lake as critical.
yep. I think that's what I'm alluding to, is that they've reached out to the federal government to try to guide the state government, if you will, to see if they're interested in making that.
What would either one of those recommendations affect me as?
Well, I don't know the answer to that question, to be honest with you. I don't know
Is there
what.
a difference between, if Mike Ferner wanted the lake to be, the federal EPA to classify it as critical, critical? Huh?
Impaired, I think, is the
Impaired?
language, yeah. Yep.
What is that, do you know what that means?
I don't know what that means. If somebody else wants to contribute to that.
Okay. I didn't know because I think we're going to need to know.
Yeah, it's possible. Yeah.
So I'll add on to that. We do know that Michigan has declared their portion of the Western Lake Erie Basin as impaired, and they did that last year. So it may be beneficial to talk to some neighbors across the border to see how that's affected them. Initially, what we're hearing at the Nature Conservancy from partners on this issue is that initially it'll just serve to keep the issue in the forefront of the news and keep people talking about the issue. And that's what we know. Any more questions for Jay? Okay, thank you.